In 1.8, we're going to address the same learning target as we did in 1.7, except now we're going to focus just on that second half, combining like terms. Like terms have the same variable and power. So an example would be something like 3x and negative 4x. That's an example. Non-examples, things that are not like terms, would look something like this. 3x and 2y. They have different variables, so they are not like terms. Another example that would, or rather another non-example, would be 2x and 5x squared. Having this exponent of 2 means they don't have the same power. They have to have the same exact exponent and the same exact variable. There cannot be any mixing of those and still have it be like terms. When we combine like terms, what we're trying to do is have fewer terms in our expression. We want to add and subtract the number part, but we don't change the variables or the powers. I'm not going to put an example there because we're going to do an example down below. Okay? The first thing I do is I pick one of the terms in my expression. Usually, I'm looking for the highest powered portion of it. I see 3x squareds. And I look to see, does anything else have x squareds as their variable? And I look at any of the other terms. I see one right here. Negative 6x squared. Yes, that negative does matter here. If I combine those, what I'm going to do is I'm going to put them right next to each other. 3x squared minus 6x squared. Then I'm going to go see, is there another term that might have a pair? Look at 4x. Anything else have the same variable and the same exponent? Yes, this last term does, negative 10x. So I'm going to put those right next to each other after it. Plus 4x minus 10x. I'm going to look for another term now. Negative 7 is a constant. Does it have any like terms? No. So I'm going to leave that in here, negative 7, but I'm not going to force something to sit right next to it. And then lastly, I see 5y. I'm going to put a box around it because I don't want to put 4 underlines. I'm going to put that at the end, plus 5y. The goal here then is to, once we've rearranged them with their like terms, see how many of that thing total are there. So how many x squareds do we have? 3 take away 6 is negative 3. We have to keep the variable with it, x squared. Just like if you had $4 and you paid $10, you'd owe $6. The unit didn't change. X squared doesn't change. In the next section, positive 4x minus 10x. You have 4, you take away 10. You now owe negative, you have more negatives, 6 x's. I'm going to bring this 5y down. It doesn't have any like terms. I'm going to just combine it. And I'm just going to place it there. And then typically we put the constant last. That is a simplified expression once we've combined our like terms. So I've gone through and I've marked what are those like terms. You could use underlines. You could use shapes. Another way we could do that is like this. Would look like this. In the first example, I see negative 2x. I also see a positive x. Those are like terms. I don't necessarily need to rewrite it where they're right next to each other either. Negative 2x plus, that's 1x. That leaves us with negative 1x. And then this 11 plus 11 is a constant. I'm going to put that right at the end. It doesn't have any like terms. We leave it just like that. We didn't change the x to become anything other than x. When we add and subtract, we keep the variable the exact same. Okay. Number 2, negative 3x and positive 15x. Those are like terms because they both have an x, which is the same variable, and they have the same power. There's no exponent we can see, so we can just combine those two. Negative 3 plus 15 becomes 12, and those were x's. Then I look to see what else is here. Negative 9 and positive 14 are also like terms because they're both constants. All constants are like terms. There's 5 more positives, so plus 5. It's entirely possible to have like terms have more than 2. We're just going to combine all the ones that are the same type. So in this expression in number 3, I see negative 4x, plus x, and plus 9x. All 3 of those are like terms because they all have an x in it and they all have the same exponent. When I add those together, negative 4x plus x, well, that's 1x. That's negative 3x. Plus 9x becomes positive 6x's. What else do we have? 5 and negative 3, those are constants. 5 and negative 3. 5 minus 3 is plus 2. In number 4, we have a lot of terms, and the goal is to simplify it by having as few terms as possible. 2x, negative 3x, negative x, and 5x all have x's in it. None of them have an exponent. I am going to add in that that's a negative 1x because we can. And then we start adding and subtracting. 2 minus 3 is negative 1. Minus 1 is negative 2x. Plus 5 becomes positive 3x's. Then we look to see what else other kind of terms we have. I see a constant, another constant, another constant, and another constant. They are all like terms with one another. So let's add. 4 plus 7 is 11. Minus 10 is 1. Plus 11 is plus 12. Positive 12. Okay. That's how we combine our like terms. The only other layer of complexity we can add here, in addition to having multiple kinds of terms, we could ask you to simplify completely, which means first distribute, then combine like terms. First distribute, then combine like terms. Why do we have to distribute first? In the order of operations, which you hopefully have seen some point in your career up till now, we try and do something in the parentheses first, then exponents, and then multiplication and division. That's all distribute is. And then the addition and subtraction pieces, that's the combining like terms. So we do multiplication and division first, and then we combine the like terms. Okay. In this one, what are we distributing? I've got a negative 2 that I'm going to multiply by each of those expressions. We have to distribute before we do 4 minus 2. We're going to end up somewhere completely different. That 4 comes along for the ride. I'm going to put a plus there to separate. That's okay, we can leave that as a placeholder. Negative 2 times 3x plus negative 2, don't need parentheses there. Negative 2 times negative 6. Let's simplify each of these terms. For negative 2 times 3 is negative 6x, so minus 6x. And then negative 2 and negative 6 make positive 12. Do we have any like terms here? Negative 6x, there's nothing to combine it with, so I'm going to leave it out front. But my constants of 4 and 12 absolutely can be combined. That becomes plus 16. Okay, so if you have something to distribute, do that before you combine any like terms. Try number 5. I'm just going to put the answer down in a moment. The answer to number 5 is x minus 1, or 1x minus 1. Check that work. Number 6, when I first distribute, we're going to distribute first. You see parentheses, we want them to go away. Negative 4 times 3x becomes negative 12x. Negative 4 times negative 1 becomes plus 4. And this plus 7x is not in the parentheses, so it is not being distributed too. We do not multiply negative 4 times 7x, so we're just going to leave plus 7x at the end. Now, we look for like terms. We've just done one underline for the first thing. Negative 12x and positive 7x. There's more negatives by 5. So negative 5x. And this 4 is a constant, and it's the only constant. So I'm going to bring down plus 4. Number 7. If you have parentheses, distribute before you combine like terms. So negative 3 is going to get multiplied into this set of parentheses. 5 stays. Negative 3 times negative 7 becomes plus 21. Negative 3 times negative 2x becomes plus 6x. I look for my variable first. There's 6x. There's no like terms. I write it 6x. 5 and 21 are like terms though because they're both constants. So plus 26. And lastly, in number 8, we might have more than one distribution. We still distribute each one and then we combine our like terms. Negative 9 times 3x becomes negative 27x. Negative 9 times positive 1 becomes negative 9. I'm going to switch colors here. Negative 1/2 times 4x becomes negative 2x. And negative 1/2 times 6 becomes negative 3. Now we look, do we have any like terms so we can write this in fewer terms if possible? Negative 27x and negative 2x makes more negatives. Negative 29x's. Negative 9 and negative 3 are also like terms. Seeing that they're both negative, we know it's going to be minus. 9 and 3 make 12. And those are our answers. So when you are distributing, you must do that first before you combine like terms, and then we look to see if there's any other like terms we can combine. Okay. Remember that if they have different variables, you cannot combine them together.